A skylight of a building is made up of grills that satisfy the properties of basic geometry of lines and angles. Do you find any relation between the lines and angles formed between the grills that make up the figure? At the end of the lesson, you should be able to recall geometrical properties of points, lines, and angles. Identify the type of angles when two or more lines intersect at a point. Differentiate between intersecting and non-intersecting lines. Describe the different pair of angles formed when two or more lines meet at a point. We have come across different angles in nature between the branches of a tree. An architect draws a plan of a building by drawing lines at different angles. In science, ray diagrams are used to study the refraction property of light when light enters from one medium to other medium with a certain angle of incidence and refraction. Do you know what concept of geometry is used here? Here, the knowledge of the properties of lines and angles is used by an architect to plot the plan of a building, and the researcher uses them to prove the properties of light by drawing ray diagrams. In our daily life, we have seen angles formed by an open book, a chopping board, and the rotating wings of the windmill. Now, take a look at the open book. Can you identify the pair of angles formed between the open pages of a book? The angles formed between the open pages with respect to its outer cover are a pair of adjacent angles. Here, angle ABD and angle DBC are adjacent angles. Ray BD is the common arm and point B is the common vertex. What is the relationship between the adjacent angles formed by the two non-common arms? When the two angles are adjacent, then the sum is always equal to the angle formed by the two non-common arms. So, angle ABC is equal to the sum of measures of angles ABD and DBC. Why do the angles ABC and ABD not form adjacent pair? Angles ABC and ABD are not adjacent angles because the non-common arms BD and BC lie on the same side of the common arm BA. What do you conclude from this? Two angles are adjacent if they have a common vertex, a common arm, and the non-common arms are on different sides of the common arm. Now, take a look at the vegetable chopping board. Can you identify the pair of angles formed by its cutting edge? The angles formed by the cutting edge with respect to the flat surface form a linear pair of angles. Here, angle ABD and angle DBC is a pair of linear angles. Ray BD is the common arm and point B is the common vertex. Why are they called linear pair of angles? Since the sum of angles ABD and DBC form 180 degrees, they are called linear pair of angles. From this, we can conclude that if the sum of two adjacent angles is 180 degrees, then they are called linear pair of angles. Now, take a look at the angles formed between the blades of the windmill. Can you identify the pair of angles formed between its blades? If the blades of the windmill are represented by two line segments AB, CD, and they intersect each other at point O, then angle AOD is vertically opposite to angle BOC. Similarly, angle AOC is vertically opposite to angle BOD. So, angles AOC, BOD, and AOD, BOC form two pairs of vertically opposite angles. When two lines intersect at a point, two pairs of vertically opposite angles are formed at their point of contact. Can you think of some relations between the angles To find this, let us closely observe the angles forming a linear pair. Here, a ray BD stands on the line AC. Angles CBD and ABD are adjacent angles. Now, measure the angles CBD and ABD and find the total measure. What do you observe? From this, we observe that the sum of the adjacent angles is 180 degrees. Thus, according to the axiom of a linear pair of angles, if a ray stands on a line, then the sum of the adjacent angles so formed is 180 degrees. Can I express the axiom the other way around? So, the converse of the axiom, if the sum of two adjacent angles is 180 degrees, then a ray stands on a line. How do you check whether the statement is true? To check this, draw two adjacent angles of different measure and keep a ruler along one of the non-common arm and observe whether the other non-common arm also lies along the ruler. Yes, both the non-common arms lie along the ruler, that is, points A O B lie on the same line and ray OC stands on it. Also, the total sum of the measure of angles AOC and COB is equal to 180 degrees. What do you infer from this? From this, we proved another axiom of the linear pair of angles. If the sum of two adjacent angles is 180 degrees, then the non-common arms of the angles form a line. We already know that the angles between the wings of the windmill form a pair of vertically opposite angles. If the line segments AB and CD intersect at point O, then angles AOC, BOD and angles AOD, BOC form a pair of vertically opposite angles. Is there any relation between the angles forming pair of vertically opposite angles? To find this, let us measure all the angles using a protractor. What do you observe? On observing the angles using a protractor, we find that measure of angle AOD is equal to measure of angle BOC, and the measure of angle AOC is equal to measure of angle BOD. We can conclude that pair of vertically opposite angles is equal. But how do you prove this using logical arguments? Here, ray OA stands on the line CD. Angles AOC and AOD form linear pair of angles. Therefore, angle AOC plus angle AOD is equal to 180 degrees. Consider this as equation 1. Similarly, ray OD stands on the line AB. Angles AOD and BOD form linear pairs of angles. Therefore, angle AOD plus angle BOD is equal to 180 degrees. Consider this as equation 2. From 1 and 2, we get angle AOC plus angle AOD is equal to angle AOD plus angle BOD, which is equal to 180 degrees. This implies that angle AOC is equal to angle BOD. Similarly, it can be proved that angle AOD is equal to angle BOC. Thus, we can conclude that if two lines intersect each other, then the vertically opposite angles are equal. We have come across traffic junctions at signals where two roads cross each other, or two one-way roads that allow flow of traffic in one direction. What type of line representations do they form? The crossroads at the traffic junction represents a pair of intersecting lines, whereas the two-way roads represents non-intersecting parallel lines. How do you say that the two lines are parallel? To find this, We draw perpendiculars at different points along these parallel lines and then measure their distances. We observe that all the lengths of perpendicular distances drawn are equal. From this, we can conclude that two lines are said to be intersecting if they meet at a common point and are parallel if perpendicular distance between them is constant. Lines XY and MN intersect at O. The ray OP stands on line XY. If angle POY is equal to 90 degrees and A is to B is equal to 2:3, find angle C. Here we have A is to B is equal to 2:3. So A is equal to 2x and B is equal to 3x. Therefore, angle XOP plus angle POY is equal to 180 degrees. This implies A plus B plus 90 is equal to 180. That is, A plus B is equal to 90 degrees. Substituting the values of A and B, we get 2x plus 3x is equal to 90 degrees. On simplifying further, we get x is equal to 18 degrees. Therefore, A is equal to 2x, that is equal to 36 degrees. And B is equal to 3x, which is equal to 54 degrees. Since ray OX stands on the line MN, angle MOX plus XON is equal to 180 degrees. That is, B plus C is equal to 180 degrees. 54 plus C is equal to 180 degrees. So, C is equal to 126 degrees.